So who here is familiar with the International Building Code 1207.2? If you'll just kind of type into the chat box, if that's something that you guys are familiar with, the STC 50 requirements for adjacent apartments, or the field STC of 45. First responder gets a shout out. Not familiar. Okay, thank you, David. So this is something that's very common in multifamily. It's basically saying from apartment to apartment, from condo to condo, you need a 50 or a 45 if field tested. And 1207.3 says IIC. And for everybody who's watching this on YouTube or seeing it through other channels, that's the same in almost every state in America. The International Building Code is being adopted at the state level, and this is one code that almost never changes. Okay, but okay, that's only multifamily. Who else cares? You know, how do you apply that to office buildings or movie theaters? Well, here is our book that we published about 6 months ago. After 6-7 years in the field, working with architects, working with contractors, understanding issues that you guys commonly run into. What does an STC rating give you? An STC 50, that's not a soundproof wall. That's still better than what we see in the field most of the time, but you can still hear a loud TV. At a 55, loud music's audible. At a 60, loud music is faintly audible. And at 65 plus, that is where you'll start hearing, that's what we design our movie theaters or world-class studios. That's what you're looking for there. And at that point, no longer do we use STC. At that point, we're looking at 100 hertz transmission. What's the low frequency transmission? So how do you guys apply that? Here is kind of a cheat sheet from our handbook as well. And everybody afterwards will make sure our contact information is available. Everybody who attends our Lunch and Learn, like today, you're welcome to a free copy of the handbook. Everybody online, we've got it for sale for like $40 on Amazon or what have you. Here is all the STCs based on different adjacencies. Okay, and we get these from a number of different sources. So brand standards for hotels. Hotel room to hotel room is usually a 55. Hotel room to corridor is a 50. That's because your door becomes your flanking path. You know, if there's no reason to have a 55 hallway wall when your door is a 35 or a 40. Residential, this has come from the International Building Code. All of these are coming from LEED version 4. So office to office should be a 45. Executive to executive should be a 50. And then we've got our ANSI S12, all of our education requirements. Classroom to restroom should be a 53. Classroom to a classroom should be a 50. Classroom to electrical or really mechanical room to any occupied space should be a 60 or higher. And then finally, we see our FGI guidelines and our THX guidelines. So what we've worked to do is give architects, instead of going out and looking at 6 or 7 standards and not knowing what you should be hitting, we've consolidated all of those into a single chart that you can say, hey, these are based on these adjacencies. Here's what I should be performing. Okay, and here's the question and answer. So everybody, please get ready for the group chat. I want to try to get some participation here. We are going to use on the left-hand side here. Once you know what your target STC is, the question becomes for architects is, you know, what should my target be and how do I achieve it in a cost-effective way? So the first thing we're going to look at is our baseline wall. That's our U497 or U465. And very similar to the 419 as well. There's minor fire testing differences based on the drywall, but all of this is type X 5/8" drywall, okay? So what we really care about for STCs is the stud spacing and gauge, as well as the mass, right? So it's all about decoupling and mass. This is an STC 44, 3 5/8", 25 gauge, 16 on center, with back cavity, back in the cavity and 5/8" type X each side. If we move from a 25 gauge to a 20 gauge, what do we think that this number in the blue is? $48. Thank you, David. Meltem and Christine and Daryl, try to give me a guess on the next one. I want to make sure. Oh, better. Thank you, Beth. Well, so that's very interesting, and that's very common. Oops, well, I can't quite get full screen here, so I'll just move this. It's a 40, okay? Interesting, right? That you go from 25 gauge to 20 gauge. That's the only change here, and you lose 4 points. Okay, and that goes back to, well, yes, so more mass, okay? And that's what David's saying right now. Mass only counts if you have 100% coverage of that mass. Okay, so the studs being heavier actually doesn't help. It makes it a more rigid wall. So we tell clients all the time, a stronger wall doesn't block more sound. A more rigid wall transmits more sound. Okay, now going back to the mass rule here. Okay, this mass is 100% coverage. It's 100% surface area spatial coverage. But what we're looking at is if you have studs that are closer together or stiffer, well, now you've got this bridge across the cavity, and you're not actually adding more mass to the entire structure. You're only adding more mass right here. Excuse me, did I skip one? Oh, okay, well, that's the problem. I skipped this one. But you are adding more mass just where the studs are, but you're not adding more mass everywhere. So in that case, you're actually losing 4 points when you go from 25 gauge to 24 gauge. Okay, now let me ask this one. We've got, you already know this assembly, it's the STC 44. Okay, we're gonna leave that as is. This time you're gonna take out bats in the cavity. Okay, so what do we think that the STC is this time? 38, 44. Okay, so somebody said it doesn't change. 2 people said 38, okay? And 1 says lower, thank you. In that case, you lose 4 points. Something we see a lot is, so 1 person thought it didn't change. 2 people think it moved down 6 points. You only gain about 3 to 4 points for bat. We see it called soundproof bat a lot. It's something I try to get out of the architect's nomenclature. It's not really soundproof bat, it's R rated. That's a thermal rating, but it does help dampen those 2 sheets, and it stops the sound that goes through the drywall into that cavity from resonating in the cavity. So you do get some benefit from bat, but it's not nearly as significant as a lot of people think that it is. Okay, so next one, 44 for our standard, our kind of control variable here. What do we think it is if you add RC on 25 gauge at 16 on center? 40. Greater, says Beth. And in this case, that's the best way to start with it. Is it better or worse? It's going to be at least better because you're only decoupling. You're not adding or subtracting mass. You're not, so your mass isn't changing at all across the entire system, but you are getting that rigid 5/8 inch Type X slightly off, if installed correctly, thank you. But you're getting it off that semi-rigid 25 gauge. 25 gauge does have some bend to it, some give. It's not like 20, which is much more rigid. But you're getting a little bit of performance. This is a very common wall that we see architects and contractors use for apartments. For NGC 2009-59, this is not achieving that minimum STC 50 that you need. It's nowhere close to getting to that 55 or better that a lot of applications require. Okay, wood studs. NGC didn't test wood, so I had to do this one. And I'll just skip this one because I'll give you the answer. To go from metal 25 gauge at 16 to 2x4 at 16, you drop to a 34. And that's because wood studs, think about how thick that cross section of the timber is. Instead of a 20 gauge, which is, you know, several more mils than 25, and it's very rigid, but not nearly as much as wood. You know, a 20 gauge stud you can bend with your hands. A 2x4 you'll never be able to bend from a cross section perspective. So you have all that rigid, wide cross section. Okay, 2+1. Okay, so I will ask on this one. This is that 34 we just saw. If you add a layer of drywall here on one side, what do we think this goes up to? You are adding mass here. You're getting full coverage on one side of the wall with doubling the drywall. The same, 36. Daryl and Melton, great guesses, 36. You're barely picking up anything because this assembly is so rigid already. At that point, adding mass doesn't really help on a rigid assembly. So a little caveat or a little anecdote I like to share here is my cousin who was building a house up in West Chase. He gives me a call. West Chase is like North Tampa, and he's got his contractor on the phone with me. He puts me on speaker. He says, "Hey, I got a 2x6 wall, and it's between the master and the kid's bedroom, and we want this wall to be soundproof, but the framing's already done, so the 2x6 are already installed." And he says, "Hey, I really want to soundproof this wall. Can I add bat in the cavity?" And I was like, well, a 2x6 at 16 on center, that's a very strong wall. And adding bat's going to give you a few points, maybe 2. And for a rigid assembly like this, he's like, hey, can I double drywall each side? If you add another layer of drywall, you're at a 37. If you add another layer of drywall after that, you're still at a 37. These diminishing returns really drop off. And so my thing is, the contractor thought he had soundproofed this wall with a 2x6 at 16 on center with double layer drywall. And he was sitting at a 37, which means you can basically hear soft chatter between the two sides of the wall. So important to remember that if your stud system's not correct up front, you're not going to get good STC performance on your walls.